Hello, and welcome to today's lesson, Algebra Skills in Geometry, Lesson 6. Our goal for today is, by the end of this lesson, be able to recognize and interpret the equations of lines in both slope-intercept and point-slope form. And then second, students will be able to write equations of perpendicular lines in both slope-intercept and point-slope form. And finally, student will be able to transfer equations from point-slope form to slope-intercept form. So now, looking at our first form, probably the most common form for a line equation is the slope-intercept form. So when we're looking at slope-intercept form, we always notice it because the y is by itself. It's a y equals equation. We've got our slope of m, and b is the y-intercept. Now, in the equation, it's an individual value, but we always want to remember that a y-intercept is a coordinate point. When x is 0, y equals b. So the y-intercept is a point. So in this case, we look at the plus 4. The plus 4 is a coordinate point when x is 0, y is 4, and that gives us a starting value to draw the rest of the graph. And then we look at our slope, and remember our slope is the change in y over the change in x. So our change in y is a -3 or a down 3 movement. Our change in x is a +2 or a right 2 movement. So to finish this line, we're going to go down 3, right 2. And we're going to put in a point. Down 3, right 2, we put in a point. Now, what we also want to understand is if we can't get enough points in one direction, we should also be able to follow the slope in the other direction. We can go left 2 and up 3 if we need an additional point. And then we can draw and connect the line from there. Okay, so now, when we're looking at the equation of each of these lines, we have to see that they can be written in different forms. The slope can look slightly different if there is no denominator value. So we always want to be aware and think about the pieces. Remember, once again, y-intercept is a coordinate value when x is 0. Think about the equation. Plug a 0 in for x. 2 times x is 0. 0 minus 1 is a -1. And our slope, we always want to think about it in terms of the relationship between y and x. So change in y, +2. Change in x, +1. So this first graph would start at -1 for a y-intercept. And for our slope, we're going to go up 2, right 1, change in y, change in x. Okay, and then we can draw the graph from there. Okay, moving to the next line here. Okay, we've got a y-intercept when x is 0. Y equals 4. Our slope is a -3. Okay, that's the numerator component, so we have to put a denominator component of 1 in with it. So we have our 0, 4 coordinate value here. And we have to go down 3 to go right 1. Okay, to put in that point, down 3, right 1 for our next point. Okay, as soon as you get 2 or 3 points, then we can work through to draw the line. Okay, notice these last two equations, written in a slightly different form. It's starting with the y-intercept. So if you always think about the idea of the y-intercept being the value when x equals 0, 3 times 0 is 0, 2 plus 0 gives us our y-intercept. So be careful, the slope is not always first. The slope is what is attached to the x value. So the slope is 3, the y-intercept is 2. Okay, now our graph is starting to get a little busy, so we just have to be careful about that. Okay, going up 3, right 1. Okay, it's a positive relationship. Notice I'm running out of space, so I need to follow the pattern back the other direction. So I'm going to go down and left, because that's negative, negative, which also gives us a positive slope. Okay, and then our last graph, okay, finishing up, if we plug in 0 for x, we get negative 5 for our y-intercept. The slope is attached to the x value. It's a positive 3/2. So this one's going to stay a little bit clear from the other graphs. We're down here at a negative 5 for our y-intercept, and we're going up 1, 2, 3, right 2, up 1, 2, 3, right 2. Okay, and then we connect the dots to finish that graph. Now, point slope form, okay, is a form that's used more when you get into pre-calculus and calculus. We want to start introducing it here so you have a chance to see it. Point slope form is fairly obvious because now there is a value with the y. The y is not by itself. And then we have the parentheses, and we also have a value plugged in with the x. Okay, the slope is always still that leading value on the x side. Okay, so when we're looking at the pieces, this is our point slope form. And point slope form is used in two ways. You're almost always given points for a graph, so it's a nice equation to write. It's one of the quicker equations to write. And sometimes the y-intercept is not a good value to graph, because we always want to try to graph a perfect point value. So in this case, our slope m is 3 over 1, change in y over change in x. And our coordinate point here, and here's where we have to be careful, it's the opposite of what we see. Notice the basic equation here. It's a minus y1 and a minus x1. So we have to understand in this scenario, it is the opposite of what we see for the x value, and it is the opposite of what we see for the y value. So now, instead of putting the y-intercept on the graph and moving our slope from there, we're putting this point that we're given on the graph, negative 4, positive 5. And now we're going to use our slope of up 3 over 1. Now notice, if we try to follow that through, we're kind of going off the graph here. Okay, so that makes it a little bit tough. So we have to remember we can follow the pattern backwards. Down 3, left 1. The negative negative also gives us a positive slope, and it gives us a better point to graph. Okay, looking at our next option here. Once again, the slope is in front of the x value multiplication. Okay, it's that distributive value. So we have a negative 1 over 1 for our slope of m. And then our coordinate point, we're looking at what's with the y, what is with the x value-wise, and it's always the opposite of that value. So the opposite of the negative 4 is a positive 4. The opposite of the positive 2 is a negative 2. And always be careful. Make sure you're starting your coordinate points in x, y fashion. So we have our point in this situation for negative 2. Okay, so we start there. We have our slope of negative 1 over 1. Okay, so always think about the negative being attached to the y value first. Down 1, right 1 for a point. Okay, and then know that we could also go up 1, left 1. Okay, it's positive and then negative that gives us the negative slope that we're looking for. So now, when we're building line equations, we can write line equations in either form. It's really based off of what information are we given, what's the quickest to find. So you're looking at the graph, we always want to look for and identify What do we have perfect point-wise? I've got a perfect point here, perfect point here, perfect point here, here, and I can go back through this side as well. So we have a lot of perfect points on the graph. So let's see what perfect points we know about. We've got this perfect point here, 0, 1. Okay, that is a y-intercept. So now slope-intercept form is in play. Every other coordinate point that we have, we could use for point-slope form. So I could use this point here, 2, 2. I could use this point up here, 6, 4. Now, what we have to do is we have to pick two of these points to identify our slope. So when we're looking from first point to second point, we can see that we're going up 1. So now we have to identify our slope. Our change in y is a +1 when I'm going from one point to the next. And remember, we always want to work left to right. And I'm going right 2, which is a positive movement. So my change in x is a +2. So now we can simplify our slope down to a 1/2 slope, up 1, right 2 for our slope value. And now we can pick anything we want to build both forms of the equation. We can build a slope-intercept because we have the slope of 1/2. Too used to point slope. I started putting parentheses in there. 1/2 x. Our y-intercept is a +1. And now I have slope-intercept form. Okay, so that's one option to write the equation for this line. The next option is we can use point slope, and we can use any point we want. I'm going to go all the way over here, and I'm going to use -6, -2 to write my next line equation. Now, for point slope, remember, it's y minus the y value equals slope times x minus the x value. And we would want to simplify this down a little bit. So we would have y plus 2 equals 1/2 x plus 6. Okay, now it's interesting. These two equations look very different, even though they're talking about the exact same line. So we're going to show in just a little bit how we could convert from one form to the other, but these two equations do represent the exact same line. Okay, now, trying to recognize based off of a given equation. As soon as you see something tacked in with the y value, we know that this is a point-slope form equation because we have too much information here. Slope-intercept, you can only have 2 pieces of information. As soon as you get 3 pieces of information, that's what turns it into a point-slope form equation. So now, the one point we know about, remember, opposite of the value with the x, opposite of the value with the y, so our point here is 2, 1, and we have to see which of these graphs has a 2, 1 point. This one does, this one does. Okay, so those two graphs so far are in play. Okay, we can't use this graph, it doesn't go through that point 2, 1. Now we identify our slope. Change in y is a +1. The change in x is a +2. Okay, so we have to find what situation from one point to the next do we have a +1 for y, +2 for the x movement. And then we found our winning graph right there. If we look at this one, it's a +2 for the y value over 1 for the x. Okay, so this slope does not match the y, or the point value matched, but the slope did not match. Okay, now, if we're going to write equations, it's always based off of the information that we're given. Here, we're given a point and we're given a slope, so the names really help us out. We need to use point-slope form. Remember, it's y minus your y value equals the slope times x minus your x value. So there's our formula. Y minus 5 equals our slope, -4, times x minus our x value, which is going to give us a +1. Okay, write the equation for the line that passes through these 2 points. Okay, now we're given 2 points, no y-intercept value, because we can see that both of the x's are not zeros. So our first step is to identify the slope. Okay, and remember, slope you can always work in either set of points for your first value. So I can go 7 minus a -1 over 5 minus 4, and if I wanted, I would get the exact same slope if I wanted to work in the other direction. -1 minus 7 over 4 minus 5. Okay, so you always have that option of what you want to pick. Here we have 8 over 1. Here we have -8 over -1. Okay, but they both end up being an 8 over 1 slope. Okay, so either way, we get our slope value. Once we have our slope, we can pick either point to write our line equation. Y minus the y value equals our slope times x minus the x value. So here's one option for that line. Okay, we could also have the same line equation using the other point. Y minus our y value of 1 equals 8 times x minus our x value of 4. So once again, the two equations look very different, but they do both represent the same line equation. Okay, now, we talked about this a little bit earlier. How can we rewrite an equation in slope-intercept form? So we have our given equation, and we want to rewrite this in slope-intercept form. Slope-intercept form just means y equals mx plus b. So we want to simplify, we want to get rid of the parentheses. Remember, the parentheses are requiring us to distribute the slope value. So we're going to distribute the slope value -0.5x. Negative times negative is a positive. Half of 4 is 2. So we're almost there. We've gotten rid of the first set of parentheses, but now we need the y value to be by itself. So we have to add 1 to both sides. And we get y equals -0.5x plus 3. And once again, we talked about this before. Notice how the equations look very different from each other, but they do represent the same thing. Now, we could do the exact same steps with this example here as well. Distribute the 2. Y plus 2 equals 2x minus 6. We subtract 2 from both sides, and now we have it down into our slope-intercept form. Okay, remember, slope-intercept is y equals form. The y is by itself. There are no parentheses. Point-slope form, okay, the y has a y-coordinate attached to it, and there is parentheses on the other side of the equation. Okay, now, if we want to find an equation for a perpendicular bisector, this is going to start to tie together some of our other topics that we have. If it's perpendicular, we have to find the slope of this line and find a perpendicular slope. The bisector means that we also need the midpoint. Okay, so in this case, we need a midpoint value and we need a slope value so we can write our line equation. So now, for midpoint, we have to average our x's, 2 plus a negative 6 divided by 2. We have to average our y values, 3 plus a negative 5 over 2. And we end up with a midpoint value of negative 4 over 2, which is negative 2. We have a y value of negative 2 over 2, or a negative 1. Okay, so when we look at this situation, it's always great to look at the graphs and see, does that point look like a midpoint, mid-segment? 1, 2, 3, 4 going down. Okay, and all I'm doing is just counting these points as I go from this middle value. 1, 2, 3, 4 going down. 1, 2, 3, 4 going up. Okay, and the fact that we have those perfect point values are actually telling us a lot about our slope situation. Our slope, the change in y, is a plus 1 over the change in x, which is also a plus 1. Okay, so we have a slope of positive 1 over 1. Now, if I need to be perpendicular, remember that we need an opposite reciprocal. Okay, so here's our original slope. What we can do is we can use some notation. Okay, we use this upside down t to show that it's a perpendicular slope to m. And since it was a positive 1 over 1, it's real easy to flip that fraction, still 1 over 1. And then we need to put a negative on the front of it to give us the opposite reciprocal. So now we have the slope we need, we have the point we need to build a perpendicular based on slope, bisector based on midpoint, and based on the information we have here, we want to write this line in point-slope form. We don't have a y-intercept. So it's y minus our y value equals our slope times x minus our x value. Okay, and in this case, minus a negative is turning both of those values to become positive values. Okay, that concludes our lesson for today. Thank you and have a good day.